Right, so welcome everyone. Welcome to our weekly call on all matters encrypted DNS related. As you should now see on your devices, we are now recording the call, so do bear that in mind. In terms of our agenda for today, we'll shortly be talking about Oblivious DoH. And the performance overhead of Oblivious, which I know will be of interest to some. We'll then go on to touch on the Mozilla consultation notice that came out towards the back end of last week. And we'll also, I'm sure, talk about IETF 109 as well, and then any other matters under any other business time permitting. So without further ado, I'd like to introduce you to Sudheesh Singanamalla from University of Washington, and certainly, at least of late, of Cloudflare. I'm not sure if you're still with Cloudflare, Sudheesh, and I know you were an intern over the summer.
I'm still working with them.
Okay, fine. So the reason I asked Sudheesh to come on was whilst some of us were attending ITF 109 last week for the ADD working group session, slightly unfortunately, one of the sessions that was running in parallel, the MAPRG session, and I've forgotten what that stands for, but it's one of the other working groups, was scheduled at the same time and included this presentation. So I figured that there's a fair chance many of us would have missed it, and since it's directly relevant to what we're interested in, then I asked Sudheesh if he'd be kind enough, as he's agreed to come on and reprise it, since he'd done all the hard work and it was potentially missed by many of the people that had an interest in his output. So without further ado, Sudheesh, I'll hand over to you. And as per our email discussion, I have the slides to hand if your screen share doesn't work. So just tell me and I'll pull them on if needed. But over to you, and thank you for coming on.
Thank you. Can you see my screen?
Yes, indeed.
Okay, thank you. Thanks for having me here, Andrew. So I'm just trying to move the video to the side. Okay, and there we go. Hi, everyone. Thank you all for being here today. And I'm Sudheesh. I'm a PhD student at the University of Washington. And I'll be presenting the measurements of a privacy-enhancing DNS protocol called ODoH, or Oblivious DNS over HTTPS. And this work is a result of a collaborative effort between lots of people at Cloudflare, and it was a part of my internship work this summer with them. And in this talk, I'll especially focus on the ODoH standard proposal that was co-authored by Apple and Cloudflare, and we're actually committed to moving this forward. As a quick introduction, as most of you might already know, DNS is the domain name system and is the foundation of the human usable internet. And it responds to client queries for host names with the corresponding IP addresses and the records. And traditionally, the DNS protocol is not encrypted, and it uses UDP, which continues to be a majority of the traffic that is received by the public recursive resolver, which Cloudflare operates. And the usage of non-encrypted DNS actually leaks user information to network operators, to on-path adversaries who might be observing the network, or even allows active attackers to modify the request from the client or the response from the server. And to overcome some of these problems, there have been a lot of recent efforts to secure DNS using DNS over TLS, or DOT, and DNS over HTTPS, or DoH. And both of these have been gaining popularity and have been integrated into various web browsers and operating systems. And these ostensibly protect client traffic from being observed by onlookers or being intercepted and changed by an attacker. But however, in this case, the resolver operator can continue to associate the client request to their IP address and build a profile around their browsing pattern. But over the last few years, we've seen a lot of active measurement research trying to understand and measure the impacts of encrypted protocols like DoH or DoT. And many large-scale measurements have shown that the performance of encrypted protocols vary by the choice of the resolver. They do not significantly impact page load times, and they improve user security. So there have also been a lot of various attempts at improving page load times by doing prefetching of some sort. But while DoH did actually improve the security of DNS queries for a lot of clients, it also received a lot of criticism about the small number of publicly available resolver services, which are essentially centralizing the internet and giving these organizations a lot of control. Additionally, these resolver operators can also associate the client queries with the client IP addresses and use the IP to geolocate the location of the client. But to maintain privacy guarantees, some operators actively decided to purge data exceeding 24 hours and give their users privacy policy-based guarantees. And bringing together organizations to agree on a common set of privacy practices to maintain user privacy needs a lot of negotiation. And for example, we've seen such examples of negotiation with Mozilla, who actively defined the criteria around data retention, the aggregation, and frequent audits of those services. And before they can actually be configured as preset defaults that are available in the Firefox browser. But some users might be comfortable with the idea of a policy-driven approach. These are difficult to enforce. They're very time-consuming, and they make users want a system that can technologically guarantee their privacy. And in this talk, I'll focus on the privacy critiques and the ability of the resolvers to being able to create a profile of their clients. This is exactly where Oblivious DNS or ODO kind of kicks in. At a high level, there are three main components of ODO. The first is the client who prepare a query for which they would like a response. And the goal of the client in ODO is to be able to successfully send encrypted messages, receive valid responses, decrypt them in the process, and be able to identify also if there are malicious actors and take any corrective actions that are necessary. The second is a proxy instance whose main role is to relay the encrypted queries and responses to and from the targets while removing the IP addresses of the client before they communicate with the resolver. And the third is the target instance, which receives the encrypted query from the client, decrypts it, and obtains the DNS response for that query. And the target's role is to then prepare the encrypted response and send it back to the proxy with no ability to identify the client who had originally requested for this information by their IP address. So at a high level, the design of ODO is similar to that of DoH, but it kind of injects this intermediate proxy node, which terminates the client query queue over here in this case, and performs the query on the client's behalf. But the guarantees for privacy, however, make this slightly different from a proxied DoH kind of a variant, right? Where the client's DoH query can be terminated and then performed by the proxy. And the main goal that we had in ODO is to prevent recursive resolvers and ISPs running such services from being able to link the clients to their request. So the client encrypts the DNS query using the hybrid public key encryption scheme, using a validated public key of the target resolver in this case, and sends the query to the proxy instance. There are various ways in which the clients can learn about these services and validate them to DNSSEC validation or look for conflicting keys for the same resolvers. However, I'll punt on this problem, but there are more details in the report that you can see towards the end of this talk. So in ODO, the proxy instance can see the IP address of the client, but not the contents of the DNS query. And it forwards this message as is to the oblivious target, which decrypts the query and obtains the response from the resolver. And the response is then encrypted by the oblivious target and sent back to the proxy. And the proxy again cannot see the response that is being sent back. So in this process, the target sees the DNS contents and not the actual IP address of the client. So we often say that the target resolver, target and target resolver are independent entities, but this need not really be true. And ideally in practice for performance reasons, the oblivious target and the recursive resolver could be co-located to avoid additional like network messages between the oblivious target and the resolver. But it is still possible to maintain them as individual services without any co-location. Now, with the understanding of the protocol in place, we set out to understand and measure three main research questions. The first one being, what is the impact of ODO on DNS response times? The second, how does ODO actually affect page load times and user experiences? And third, how does ODO compare itself to other privacy enhancing variants that are out there today? And this helped us understand the cost of privacy for the user while maintaining these security guarantees that are provided by encrypted DNS protocols. And this slide is very verbose, and it pretty much sums up the results of our measurement study and is probably of the most interest to all of you. But I'll leave this here as a reference and go through each one of these in detail, so you can always revisit this slide whenever it's necessary. So let's get to the measurement. We implement and deploy the oblivious targets and proxies using Google Cloud and a serverless platform like Cloudflare Workers. And we physically separate the oblivious target instances from the resolvers and randomize the query that goes from each of the targets to the resolvers by choosing three public resolvers. That's Cloudflare DNS, Google DNS, and Quad9, which we use in our measurements. So we use 9 Google Cloud data center locations, 7 across the United States, 1 in Montreal in Canada, and 1 in Sao Paulo in Brazil, with 10 client instances that are running at each of these vantage points, performing an experiment sending DNS requests at a rate of 15 requests per minute, which is the average number of DNS requests sent by client devices with high internet usage. And the average bandwidth for all the clients running on a single core Intel Xeon processor is roughly 480 megabits per second. So the clients perform DNS response time measurements by choosing the pairs of proxies and targets. And in the process, we see that by choosing a low latency proxy target pair for the measurement, as shown in the orange line over here, we find that the average query response time improves by 22.8% compared to only choosing a low latency proxy, which is shown by the green line here. And this kind of hints towards the fact that having an intermediate proxy on the same network path to the target will improve response time performance. And this path, however, can be quite different from the path that a UDP-based DNS packet might travel on. But what about connection reuse? And connection reuse is an optimization that can enable clients to improve their performance by at least 46% on an average, avoiding unnecessary TCP and TLS handshakes on every request, which you can see on the orange line here compared to the blue line without the connection reuse. And in our experimental setup, we evaluate for the worst case performance and incur this additional latency, as I mentioned, between the target instance and the resolver. So as we can see here, the target instances which are located in Google Cloud and are performing queries to 3 public open resolvers have a faster response time for Google DNS, which is in green. And this is possibly because of potential co-location within the same data center compared to the other services. And integrating the oblivious target into the recursive resolver can reduce this network latency incurred to that of a cache hit for the answer, and a cache miss incurring the network cost by the recursive resolver, which actually communicates with the other name servers. And we find that co-locating these services actually results in better performance. So to understand the performance of ODO, we compare these to other protocols offering similar privacy and security guarantees and use DoH as the baseline protocol, which is shown here on the indigo line to the left. And DoH over Tor is a variant of DoH which provides both the security and privacy guarantees in addition to some anonymity guarantees. And this is the beige line that you see on the right side of the figure over here. When compared to ODO, we kind of notice that ODO with no service co-location achieves an interesting position roughly in between DoH and DoH over Tor. And sorry, I can hear myself. Okay. Sorry. So you see there's an interesting middle ground that it kind of achieves. And these results further get more interesting and better as we start to co-locate the target and the resolver together, which is shown by the dashed blue line in this figure. And we noticed that the response times for Odo compared to DoH as the baseline increases on an average by 50% with service co-location and 100% when the target and resolver are not co-located. So DNS protocols with message encryption like DNS Crypt tend to have much larger compute overheads and use non-encrypted channels. But these protocols also have a much higher response time and lie somewhere in between Odo and DoH over Tor, which is shown by the dotted arrow over here. And so this brings us to like a crucial measurement that we're really interested in, which is the page load time impact. And to do this, we establish a measurement node in a lab network with an available on-path proxy and with a randomly chosen off-path proxy in the same geographic area. And the node runs a local stub resolver, which is configured to use DoH or the Odo protocol for various runs. And in each run, the web browser is set to load the same set of pages after purging all the local cache entries. And they perform the web load page load measurements with Selenium while using the W3C navigation events to identify the various page load events that might have occurred. And our measurements that are presented here are actually very pessimistic and use the worst case network architecture with no service co-location. And they also only consider the complete page load events instead of other metrics like time to first byte or first useful paint, which are generally used in measurements. So additionally, there are a lot of browser artifacts like caching, which could result in the top graph over here looking very different from the kind of the stress test measurements that we've seen before. So what we do find is that there is an increase in DNS response times, but the overall page load time when using an on-path proxy increases by 20% compared to the baseline UDP usage of DNS or DoH, and using an off-path proxy increases it by 25%. So to give you concrete numbers, this changes from 1.319 seconds on an average for page load times using DO53 with UDP to 1.60 seconds with Odo. But these results are still preliminary, and with service co-location, the performance of this might improve, and we are actively working towards this, and we are optimistic. So this is still ongoing work. And to conclude, Odo is a practical privacy-enhancing protocol for DNS, and it has minimal page load time impacts, and the performance impacts of the protocol are purely network topology effects. So in the actual report, we make some recommendations for ideal usage in production systems and how maybe a community or a network of or an ecosystem of on-path proxies, service co-location by the DNS resolver operators, and connection reuse from the stub resolvers can actually help improve these results. So all the code and the implementation is open source, and they're all available at these links at GitHub under the Cloudflare organization. And we're committed to moving this forward in the IETF as we presented, and hope that more operators join us in providing the support for this protocol, either by running proxies or the targets. And the report indicating our measurements and more details is available on archive and also available on a personal link on my webpage. And thank you. I'm open to questions if there are any.
Perfect. Thank you very much, Sudheesh, for that very rapid run through. I'm guessing this will be of particular interest to those of you that are currently operating resolvers, and that may throw up some questions and comments. But if anyone has any questions, comments, or other observations, if you are able to raise your virtual hand, that'd be helpful. If for any reason you can't come off mute, feel free to put a question or comment in the chat and I'll read it out. Anyone have any questions? I see John is first off the mark. So John, do you want to come off mute and fire away? John Todd, that is, for clarity.
Can you hear me? No.
Oh, that's better. I can hear you now, John.
My microphone has lost its mind. Can you hear me now?
Yep.
All right. Is that a yes? Can you hear me?
Yep,
Yes.
I can hear you.
All right, great. Now I've got some kind of lag going on my Zoom client here. So it seems like the biggest, one of the biggest improvements was the connection reuse. How is connection reuse with Oblivious DoH significantly different than connection reuse just with standard DoH, or is there no difference? In other words, is it unique to Oblivious DoH, or is it just that connection reuse is much better?
Connection reuse in general is much better. I think there was an IMC paper in 2019 which spoke about the comparison of DoH and DOT and the role of connection reuse in DoH. So there's nothing really very different about connection reuse compared to DoH. So if there is a stub resolver that uses DoH, it is very easy for that stub resolver to integrate the ODO protocol also.
Thanks, John. I can see two comments in the chat, which I'll read out. First, from Kurt, I think, which is literally just a comment, which is just logging these against the use of DNS tasks in apps, and that it really ought to be done in the operating system rather than the app directly, which I think is a fair comment. However, that's the decision that was taken within the IETF to provide access to DNS within apps. So but that's a discussion to be had, but maybe somewhere else. I'll read Paul's question, then come on to Ralph, who raised his virtual hand. So Paul asked in the chat, what privacy benefits come from Oblivious DoH that are not guaranteed by the Mozilla Core TRR rules, which will link us nicely to the discussion we'll have in a minute about the Mozilla TRR. So I don't know, Sudheesh, if you have any views on ODO versus Mozilla's TRR.
Right. So as I mentioned, I think this is a great question, and this is one of the questions that I kept thinking about when I started my internship, and this was a project that I could potentially pick, was why would someone do this? And as I mentioned in the talk, the impact really is there are some users who don't want things to be just based on privacy policy, right? And over there, they would need a technological way in which they can guarantee this privacy. So if there are a set of proxies which whose IP addresses are instead exposed, are like captured by the DNS resolvers in this case, the client's IP address is still protected. So that way, the privacy benefits are more technological guarantees than policy or like legal guarantees.
So I guess it solves the problem that some of us were grappling with last week in some of the IETF discussions about trust. You don't need to trust anyone, potentially.
Right. And I kind of burned through this pretty quickly, but in the report we do mention that the main goal is we don't want the proxy and the target to be colluding. So it's okay for the targets and resolvers to be co-located purely for performance, right? But we want users to be able to have the flexibility to choose the proxies and the targets in such a way that they know these belong to two separate organizations, which will definitely not collude.
Yeah, fair point. Okay, Ralph, you raised your virtual hand. Fire away.
Yeah. So the question I have, I mean, especially on connection reuse. If you have a normal stub resolver that talks to one server, for this protocol it has to talk to multiple servers. I'm not sure in your measurement. So did you actually specify the amount of servers it's going through? Or, I mean, you probably, when you're using ODO, have multiple proxy targets. And these also need to be looked up, and how would
Ralph, I lost your voice for a while. I don't know if it was just me.
No, you did break up a bit there, Ralph. Do you want to try that again? Ralph's just checking his audio stream, I assume. All right, Ralph, do you want to try that again? You broke off partway through the question. Try that one last time. Ralph, if you can hear me, do you want to try that again? You broke off partway through your question.
Yeah, I can hear you, and I sort of also had a. So the question is, there are multiple connections from a regular resolver to an ODO kind of resolver client library. How many connections did you kind of calculate on being sort of done over a period of time? And on the latency measurements, did you also include the latency that is needed for the lookup of the SCCB records and follow-ups?
So I don't have the exact numbers for that, but one of the things that we do in the connection reuse is we stream connections in like bunches of say 15 to 20. And after 20, we assume that maybe this is over a minute. We don't want to keep the connection lived longer than that. We terminate the HTTPS connection and restart it. So that is, I guess, for the connection reuse bit, but I did not really understand the second part of your question about lookups.
Well, I mean, for to find a target for a Odo, a target and a proxy for Odo, you need to do lookups, SVCB lookups. Are these included in the measurements, or are they kind of assumed that they are there? If they are cold cache.
Yeah, these are assumed to be like prefetched as like a bootstrap process. So we do indicate how the bootstrap process works in the report. But you could think of it something similar to like the way DNS Crypt does it, where there is a community sourced version of like, here are a list of available proxies, or here are a list of available like resolvers which support this protocol. And the client's responsibility is to query each one of these, validate the DNSSEC signed like public keys, and then store them, see if there are conflicting public keys, for example, then making some decision on the trust of that resolver.
Okay. And how many connections did you kind of assume a regular kind of client would have to different targets?
So we roughly assume the rate of them as 15 per minute.
Okay.
And this is kind of the metrics that we see for like the 90 percentile or 95 percentile of the most frequent kind of queries that we get from a user.
Okay, thanks.
Yeah, thank you.
Thanks, Ralph. And you've answered, I'll just go through some of the questions in the chat. I think you've answered Greg's question just there, Sudheesh. Is there an optimum amount of connection reuse, i.e. how long do you keep a session open before you close it down? I think you said a minute was your assumed maximum length. Was that partly for privacy reasons, Sudheesh, as much as anything?
So we do have a side note in the report which says that so if you reuse the session key of your HTTPS query, it could be privacy sensitive. Like you could leak some information about the ID or like who is actually sending this, but it does not, we say that while this could be a privacy issue, there is no leakage of either the encrypted data or the in the HTTPS connection itself, or the encrypted like real data that's being sent in the response. So it feels like it is a problem, but there, if I was a stub resolver, if I was implementing this in the stub resolver, there would probably be a configuration for users who care a lot more about this to issue a new HTTPS connection every single time.
Yeah, and take the performance hit.
Yes, and they would take the performance hit for that.
Yeah, fair enough. Okay, question from Jason from Charter. What is the use case for Odo if the same provider runs a proxy and the DoH server? If you use IPv6 privacy addresses, doesn't that get you close to the same goal?
So I have to admit, I don't know anything about the IPv6 privacy addresses, but maybe I can answer the first part. We do mention that, so there's really nothing that gets added for privacy for if the proxy operator and the resolver operator are the same, right? And it's not even recommended to kind of do this, because why incur an additional network hop when you can directly speak to the resolver if you already trust the resolver? So it depends very heavily, I guess, on the trust model of the user. If the user trusts the recursive resolver directly, they could make a DoH query. But if the user does not trust the recursive resolver in maintaining or in like deleting their information or doing anything of that sort, they could proxy it through someone else's proxy. And these proxies could be like a community driven, like Tor nodes, I guess.
Yeah.
Yeah.
Yeah. Okay. Okay, it's a slightly different tack from Greg on this one, which is how do CDNs view obscuring the client IP? So this is looking at a different part of performance, I think, which is the CDNs tend to want to know this first selecting an appropriate content cache. So I'm not, do you look at that at all, Sudheesh? Or
so we do say that it does affect like EDNS 0 kind of client subnet optimizations that are in place, but the optimizations for that are based on the IP of the proxy. So wherever the proxy is, the optimizations for that would continue to work, assuming that the proxy is the client that the resolver sees. But I haven't actively measured what the impact of the CDN would be on this, but I'm assuming that some of these results would be masked inside the page load time measurements that we've done. So drilling through the page load time measurements in more detail might give us some more information for this answer, but I don't have an answer for you up front.
thank you. I'll ask Paul's question, then come on to Chris, who's raised his hand. So Paul's question first. Definitely not collude ultimately depends on trust, just as TRR does. Okay, it's a comment rather than a question, apologies. So that was a statement rather than a question. So yep, I think reasonable comment, Paul, thank you. And Simon just has put RH in the chat, which I'm not sure, that might be a typo. So if that's a question, by all means,
raise hand.
Oh, raise hand. All right, okay. I think you possibly did that before Chris raised his hand in that case, Simon. So you come in and then Chris, and then we'll be up to date so far in the queue. So far.
Apologies, the Mac client doesn't seem to have caught up with the raise hand function yet. I'm a government person, so maybe you could say I might ask these questions, mightn't I? Could you comment on the use of this protocol if we're using from the DNS side of things for filtering and blocking at the sender end, and also on the implications for lawful interception? Thank you.
Right. So I'm not an expert in this area, so you should take whatever I say with a grain of salt.
I'm not either, so you're fine.
And so this is something we have definitely thought about, and there is an entire discussion section in the report towards the end of the report, which kind of goes into this. It is possible for a very motivated person to kind of see if they can circumvent the DNS level filtering guidelines that are put in by a specific country, right? So every country has their own kind of DNS filtering rules and regulations in place. So it is possible for someone to kind of do that, but to do that, they might have to either tweak or make some kind of changes to the way this works. By, say, for example, from the US, I choose a proxy that is in Canada, and for some reason, the connection to that proxy was not intercepted or was not canceled out. From there, I can use so now it's in Canada's, like, I guess, legal regulation or jurisdiction to whether they want to serve the IP address or not. So it does kind of slightly impact the DNS filtering policies that are in place, but it is still possible for, say, the parental controls that a lot of DNS operators provide. It is still possible to kind of apply those protocols in the country in which the resolver or the request is coming from. So if I choose a proxy that is in Germany and it connects to a German resolver because that's the closest, the rules that apply in Germany would apply to that resolver. So that part of it is still unchanged and it works as is, but it is quite possible for someone who is highly motivated to kind of do something like this. I don't know if that answers your question, if that makes you feel better, but one of the things we do recommend is slowly moving from DNS-based filtering to, now the filtering would have to move to IP-based filtering, where you're looking at the IP traffic and you're trying to actively find out which websites are probably like rotating their IP addresses or keeping their IP addresses static and blocking them or censoring them as necessary.
Thank you. Yes, I think effectively you told me what I thought I saw from the presentation, and that if we wanted to use this protocol in its purest form, we'd probably have to impose some sort of regulatory constraints on how it was used if we were to have it, as it were. If we want the sort of features I was describing within the current sort of framework of how we operate. Okay, thank you.
So that's the reason why we do mention the thing about on-path proxies being in the same geographic path location. The idea is to give privacy to the users in that specific country while allowing them to browse privately and improve their privacy, but not to help them circumvent any kind of regulations that are in place.
Yeah, so you can, as it were, run the protocol in that way, in a way that will satisfy, say, sort of any constraints we want to put in from a state level, as well as providing privacy for the users. Okay, thanks.
Right. Yeah, thank you. This is still an active work in progress, so there are a lot of legal teams that are looking at.
Oh yes, I appreciate it's a theoretical concept rather than something that's actually on offer at this point in time. Thanks.
Okay, thank you. Okay, last but not least, Chris, you have your hand raised. So do you want to come off mute and jump on?
Yep. So I've actually now got an additional question after your response to Simon. So one of the things you just said to Simon was you kind of recommend that any filtering is applied at IP level instead of DNS level. Isn't that kind of impossible, given that most content is served from a cloud of some kind, and therefore the IP ranges are huge and numerous, and also the services that run on them are all co-located?
Right. So I don't know this space well enough, like how you could enforce these kind of regulations, or neither do I know the regulatory space well enough. But one of the things that we were careful about was to kind of think about how parental controls, which is pretty much, I guess, in the same ballpark, in the same wheelhouse of things, how they might be affected because of doing something like this.
Okay.
So to do this, if there is if you have a stub resolver, which is say a Raspberry Pi or some kind of a Pi-hole kind of a setup at home, the Pi-hole could run the validation to see if this specific website or if this specific domain name is in the allow list or the deny list, and whether it hits the parental control filters. So there is filtering that needs to happen probably at the final client's side of things, if they're in a home network and if parental controls need to be applied. But from a broader, if I was an ISP and if I did not want someone to access specific content, that gets slightly harder. So we do acknowledge that it starts to get harder.
Yeah. Okay.
Yeah.
I think I agree. It is hard. I think, yeah, I mean, my personal view on filtering, if filtering happens to happen on a, let's say for a malware command and control server, you might be lucky that it's hosted on a particular IP address, but in the general case it won't be, and so your own route that is available for blocking that, I would say, is probably at the recursive DNS resolver.
Right.
And obviously Oblivious DoH can change where that recursive is, because that's the target. It's called the target resolver in this, isn't it?
Mm-hmm.
I'll come on to my question I was originally going to ask, which was in response to Greg's question too. So you talked about, the question there was about choosing the CDN edge node that's going to serve the content. Yeah, if you're loading a web page. And I think you said the CDN, when it receives the DNS query, it's going to make that decision based on the IP address and the location of the proxy. Right. So, okay, that makes sense. So does it then mean that if the content is then going to be served in the same country as the proxy? So if I'm sitting here in the UK and I choose a proxy that's in the USA, I'm likely to be served content from the USA. Is that true?
If there are websites which have Yeah, I mean, say for example, you're trying to browse cloudflare.com and you choose a proxy that is in the US, say in New York, for example.
Yeah.
And so there's a very high chance that the closest IP address that the resolver in New York responds to is the IP to the cloudflare.com website in New York. So you would be hitting the request in the US data center. But if the US data center serves you based on your IP, now the machine in the data center knows your IP address because the next subsequent connection that you make is directly to that machine. So they could take some decisions over there based on your IP if they think that, oh, you're from the UK, so let's start serving you UK information. But yes, you would be hitting the US data center, a different data center where the CDN is. So that does sometimes maybe it could change the kind of content that you're served, maybe the language of the content or anything of that sort.
Okay, yeah. So essentially, the locality of the content that you obtain, it moves from being fine-grained, particularly in the sense of the BT network, where there are a lot of CDN deployments spread throughout the country. It moves from that fine-grained location to a coarser awareness of location. And I guess it is in the client's control as to which proxy they choose.
Right.
And
so
they would be advised to choose a proxy in the same country to at least get reasonable locality. But I guess unless there is a deployment of a proxy in every city and the clients choose those in the same city, then yeah, I guess it inevitably means the content will be less local.
Right. So we do mention that it is recommended to have an on-path proxy, which is probably which means that it's potentially in the same geographic area as the client, except that you don't want the idea is to give the client privacy, but ensure that the client is probably still operating within the same geographic area where there are maybe a set of rules and regulations that need to be accomplished. But if the client chooses an off-path proxy, say in a different country altogether, or maybe a different continent, then the client will go through a significant performance hit in terms of like the response times, page load times, and so on.
Yeah.
Yeah.
So there could be a trade-off here between privacy, well, as always is the case in fairness, between privacy and performance, which I guess is not a headline. That's always indeed the case in fairness. Okay, I'm conscious of the time, so if we could move on. John raised his hand, so last question to John, then we will move on to the Mozilla TRR. So John, if you want to
Sure, this is a combination of comment and question. So to address some of the concerns in these last couple of conversations, all we're really talking about is moving away from essentially anycast DNS systems which use the same IP address and they appear in multiple geographies, to now moving backwards in time to, all right, well, I want to pick a proxy that is not anycast, or that the assumption in these conversations has been that the proxies are not an anycast solution. They could very well be an anycast solution. So that would therefore more strictly regulate your geography and where your queries are coming from. I guess my question is, did you contemplate the use of anycast in any of your analysis, or determine how anycast for proxies might affect the response time or load talking to the recursive resolver or the translated resolver in the back end?
So that's the reason why we say these are very pessimistic figures. It is possible for like any of the current anycast DNS resolvers like Quad 1, Quad 8, or Quad 9, for example, to provide the provision of a proxy and proxy the request to someone else. That could in general make things much faster. But then you're still operating in the same like geographic area with the same rules and regulations that are in place in that case. So yes, your comment is right. You could operate a proxy at the anycast edge.
Okay. Thanks, John. And those of you that are looking at the chat will see that Pat has posted some comments about IP address blocking, as has Colin. So I'll include those in the notes so people can read those at their leisure. So Sudheesh, thank you for that. That's much appreciated. And it's good to see some actual data informing some of the considerations around Oblivious, just to add to the previous sort of papers. So that, I think that's incredibly helpful. And let's hope there's going to be plenty more measurement papers on other subjects coming up from others as well. Yeah, because this is going to be increasingly important.
Thank you so much.
So you're welcome to stay on, by the way, but we will move on subject matter now to talk about the Mozilla consultation. So just as a reminder, and I will put this on the screen so you can see it. Hopefully you can see that. Can you see the Mozilla a comment paper coming up? I hope you can. Yeah, so this is just the email that came out last week from Mozilla announcing that they're starting a consultation period on the TRR to basically move outside of the US, where it's been focused thus far. So as a reminder, just up until now, the TRR has incorporated Cloudflare initially, and then latterly Next DNS and Comcast. So 3 resolvers in the US, and they're starting within this consultation. As I scroll down, there's some sort of background there. Through to the 4th of January. So if you're interested, you've got through to the very beginning of next calendar year to go through and answer the consultation, which if I link to that, you'll see it comes up with a series of questions around sort of various topics such as privacy, safety, etc. So really what I wanted to do, if I just leave that up on the screen for a moment, was really just to highlight that, like that, given that it came out last week, when I know quite a few people had their attention focused on the ITF, just to make sure it didn't get missed in your no doubt backed up inboxes, and then really just give anyone an opportunity to just comment on it if you wish. Don't feel like you need to, but just wanted to just put it up there. I have, by the way, reached out to Mozilla, and we'll give them the opportunity to come onto the call in the sort of future weeks if they wish to as well. But it just seemed sensible, whilst it was topical, just to throw it up there and see if anyone had any observations or questions on it before we move on. So as we just now, if anyone has any comments you wish to make, feel free to raise your virtual hand or indeed put them in the chat if you wish. I'll give you a minute or so to do that if you wish to. I see actually one on there, which is Pat, will Eddie respond to the Mozilla consultation? I've not had a discussion with Glenn Dean, but I doubt very much that Eddie will, as it's a sort of loose-knit voluntary network. That's my interpretation of it. I'm sure Glenn would word it much better than that. So I doubt that Eddie would, as an entity, because it isn't really an entity in that sense. So as far as I'm aware, it will be down to individuals, although of course we can, through this call, if the Mozilla team do come on, there's an opportunity to clearly sort of have a discussion with them there if you wish. And I can see that some people have already just started that. So I think Paul's possibly one of the first respondees. That's impressively quick, Paul, to respond. Hopefully there will be many others in the next sort of month and a half or so. So any other thoughts or observations from anyone else other than Paul? Or indeed, Paul, was it, how did you find it? Was it pretty straightforward, just going through the questions?
I did not answer their questions.
Which is not untypical for many people doing consultation responses, to put in a response that not necessarily covers the points from the sponsor requested, but we've all done that in the past, so that's fair enough. Okay, well, if anyone does have any thoughts over the sort of coming days, which you may not have had a chance to even look at it yet, if you were out last week, then yeah, I think this is a subject we may well come back to in the next few weeks. I see it's also been raised on the Internet Society's list, mailing list, and others, so it's certainly garnering some attention at the moment. Okay, let's move on then. We're sort of in any other business. I'll maybe start just by raising ITF 109. I think we had a good set of discussions, certainly in the ADD working group, an extensive discussion on what equivalence means in the context of the use case that Chris Box raised. Which was possibly longer than any of us may have envisaged, but I think we've had a thorough examination of equivalence as a topic, and various other areas. I don't know if anyone had any, again, any points you wanted to just briefly highlight, looking back on last week, in terms of how you found it. I'm going to give you a chance to come off mute if you wish. Or are you still virtually jet lagged from the time zone difference, quite possibly? Just while you're thinking, in case you missed the point, I think towards the end of the second ADD session, I think the intent is to likely have at least one sort of virtual working group session between now and March. And from memory, I think the back end of January, early February was discussed as the likely timing for such a session. So no doubt our two co-chairs will put their thoughts out on that in the next few weeks. Okay, and I can see that Paul's put some further sort of food for thought on the consultation in the chat, which again, if you're okay with it, Paul, I'll put that into the notes to prompt the thinking from others.
No problem.
Perfect, thanks. Okay, anything else that anyone else wishes to raise whilst we're gathered together in the last couple of minutes or so? I think people really are sort of pretty much sort of exhausted after last week, probably. So okay, well, look, on that note, let's call a halt there. Thanks very much again, Sudheesh, for your presentation. That's much appreciated, and a real shame that there was a conflict in the timing at ITF, because it would have been a real pity for that to be missed. And as I say, no doubt we'll sort of revisit the discussion on the Mozilla consultation in the next few weeks, and I'll pop out a note if I get a response from the Mozilla team and they are willing to come on to a call to actually have a live chat, which I think would be very useful if they do. But with that in mind, have a great week, everyone, and we'll speak again this time next week. Thanks all for your time.
Thanks all.
Thank you.